Okay. These two questions are kind of what you found in the geometry section, okay? Most people didn't do the geometry. And those that didn't usually get it all, so figured that should be an easy assignment. But we're going to talk a little bit more about that today, so you can talk about it. Over here, these problems simply rely on what I told you last time, but we said it kind of briefly. Something that you would hopefully have used on your homework. So before I get into these, well, let me just kind of discuss this, because you're going to need it on the homework for this time. You're going to need it throughout the course at the various times. Okay, so let's say I've just got a simple equation like x over 6 minus 3 equals 5. Now, I multiply both sides by 6. Now, it doesn't mean I multiply this by 6 and don't multiply anything else by 6, because that would change the whole equation. I multiply this side by 6, and I multiply this side by 6. So I write out 6 multiplied by x over 6 minus 3 equals 6 multiplied by 5. 6 parentheses everything in this side, 6 parentheses everything in this side. So just whatever these sides are worth, I made them both worth 6 times as much. Well, if this is equal to this, then 6 times this has to equal 6 times this. Okay? If you only multiply part of it by 6, you're not doing that, then you no longer have equality. Okay, if you just multiply this by 6, sides wouldn't be equal anymore. Okay, so we do this. And then we write that as 6 times x over 6 minus 6 times 3 equals 30. And 6 times x over 6 is just x, as went through quite a bit last time. So I'll have 2 dots there to indicate behind yourself what we did last time to show why 6 times x over 6 is x. Because you need to remind yourself of that. When the expressions get more complicated, you're going to want to be sure you understand why it works here. Okay. Anyhow, you get x minus 18 equals 6. I'm just going to put 3 dots here because you know what you add 18, you get 48. Then you go back and check it. Well, 48 divided by 6 is 8, and 8 minus 3 is 5. Okay. I'm going to reiterate that one emphasize checking. And now we have the correct solution. Okay. Now I'm going to ask you to give you a slightly easier problem. Right now, go ahead and see if you can do this. First of all, I saw a couple of mistakes on the distributive law. So let's be sure we understand the distributive law. Says that A times B plus C equals A times B plus A times C. If A multiplies B plus C, then you got to multiply B by A and add it to what you get when you multiply C by A. Okay? So you need to lock that in. And if you made a mistake on that, big letters, write out what I just wrote out here and make sure you always have a reference. Okay, then, of course, there's another way of stating it, but I'm going to stick with this for right now. Okay. Yeah, well, okay, the other way of saying it's stating it, if you have the A plus B multiplied by C, well, that would be A times C plus B times C. Okay, now how does that apply up here? Well, let's say I have X over 9 plus 2 equals X minus 4. I can't multiply just this by 9. I can't multiply this side by 9 and not multiply this side by 9. I have to multiply both sides by the same number. Okay? Both sides, because again, as I said before, this side is equal to this one. Then if I multiply part of this side by 9 and not another part, it's no longer equal. So it's not an equivalent equation. But if I multiply both sides of two equal quantities, and if I multiply the quantities on both sides of an equal sign by 9 or any other number except 0, they're still going to be equal. If they're equal and then they both grow 9 times as big, they're still equal. That makes sense? So you want to kind of think of it that way. As I did here, you see what I did. Here I multiplied 6 by both sides, right? 6 by this side, all sides in parentheses, because the whole thing has to be multiplied by 6. And then same thing on this side. Now this side was pretty simple, it was just 6 and then parentheses 5. Well, I did the same thing over here. Of course, this side was a little longer. So I really needed those parentheses to be sure that I multiplied 9 by the whole thing. Now, if I do that, I get by the distributive law, I get 9 times X over 9 plus 9 times 2. That plus is really important. Okay, a couple of you kind of left off your operator here because you're concentrating on just the multiplication and you kind of forgot that there was a symbol there. Okay, now you get used to that real quick. Just get the habit of doing it right. Okay, and then nine times X minus 9 times 4. Now this works if it's a minus here. If it's a plus here, it's a plus here. If it's a minus here, it's a minus here. There's a more detailed reason for that, but I'm not going to confuse you with it. Okay, then I put a few dots here because there's work to do to see why 9 times X over 9 is equal to X. We'll talk about that fairly extensively, and we'll repeat it as necessary. But if we multiply everything out, we get X plus 18 equals 9X minus 36. Now, what do we do with this? Well, it's not quite as simple as this because we have X's on both sides and numbers on both sides. So we're going to get all the X's on one side. So we're going to do a couple of steps. Let's go ahead and subtract 18 from both sides, which gives us X equals 9X minus 54. Now, if X equals 9X minus 54, well, that's not a solution for X because you still don't know what X is. Say X, okay, X is 9X minus 54. I want a number for X. I want a solution for X. So what I need to do is I need to add 54 to, subtract 9X from both sides. So I'll rewrite it up here. X is 9X minus 54. Now I subtracted 9X from both sides. So I'm going to just have no X over here. And I get X minus 9X. Well, that's 1X minus 9X. Gives me minus 8X. And that equals minus 54. Then I divide both sides by 8. By -8. Forget that. Put a few dots here to remind myself to think, okay, that's going to be 8 over 8 times x over 1. That's going to be 1 times x over 1. That's going to be x. Make sure we understand that. And for now, I say you need to write out those steps. Want to see you write out those steps. I'll lose less sleep worrying about you. And if you include those steps, okay? And then negative 54 over negative 8 becomes negative 27, well, 27 fourths. Okay. And then we go back in for x, and we get 27 fourths over 9 plus 2 equals x minus 4. Okay, well, that's the same as 27 fourths times 1/9 plus 2. And that's the next thing, that's 27 fourths. And you can do the fraction. This gives you 3/4 plus 2. And this gives you 6 and 3/4 minus 4. You get 2 and 3/4 on each side. And checks. Got a little work to do with fractions there. Of course, you want to be lazy about it. Once you get this, just multiply both sides by 9, and it gets a little simpler. Then you still got a denominator 4, so you got to multiply both sides by 4, and then it gets real simple, and you can do it. We're not going to mess with it here because we're going to have to try to put it over here. Okay. Okay, so let's see what you do with this equation and this one. Okay, now what's the rule that we're working on here? Well, there are a couple of them. There's a distributive law, but that's something that we assume everybody can use correctly, okay? And those are using just fine, but some people need a little clarification, and that's fine. But the thing that we're after here, the thing that we're trying to do is we multiply both sides by the denominator to get rid of the denominator. And the way I wrote that before is eliminate the denominator by multiplying. And that was the short statement I gave you last time. The longer statement there's a better way to write this. I'd say multiplying both sides by the common denominator. I want you to see why we use a common denominator. So just kind of write it like this. Okay. So we can multiply both sides by any quantity we want, as long as it isn't 0. So we write this. What do we got for denominator here? It's x. Right there it is in the denominator. Both. It's twice, which is convenient. Okay. It's in the denominator. So we have x multiplied by 7 over x plus 4 equals x multiplied by 3 over x minus 6. Now, when we multiply this out, we write it one step at a time. We don't skip steps. We don't write something down because it looks right. I mean, sometimes we do because we got to make a guess. Okay, but If you do that, it's very likely not going to work out unless you really know what you're looking at. And the way you learn what you're looking at is by following the rules. And the rule is we use the distributive law and write it out very explicitly. X multiplied by 7 over x plus x multiplied by 4 equals x multiplied by 3 over x minus x multiplied by 6. At this stage, open math will probably tell you just cross these x's out. That's cancellation. Nobody understands rules for cancellations. So people end up doing it wrong again, and again. If we don't understand why cancellation works. Okay, reason the x's go away here. It just leaves you with 7 here. It leaves you with 3 here. Okay, that leaves you what you have over here. This is the 3 dots that I've been writing down. That we need to continue writing down so we're sure we have this. Okay. There it is. Okay, now you had an early assignment on multiplying fractions. So we should understand that when you multiply these fractions, you multiply the numerators and multiply the denominators. When you add fractions, you don't just add the numerators and add the denominators. You have to use the common denominator. Okay. Now, x times 7 over x is the same as x over x times 7 over 1. Why is that true? Well, if you multiply these numerators, x times 7, don't you get 7x? If you multiply these numerators, you get 7x. Because in both cases, in your numerator, you're multiplying x by 7. So it's going to be the same, whether you write it in this order or this order. And what do you get if you multiply 1 by x? Show me with your fingers. Yeah, okay. And across your fingers. Okay, 1 times x is x because 1 is your multiplicative identity. It's called the multiplicative identity. If you have 1 of something, that's what you have, something. So x is the same as 1 times x. You are the same as 1 of you. Okay. Okay, so you got the x over x times 7 over 1. X over x is equal to what? Yeah. 1. So we have 1 times 7 over 1. What's 1 times 7 over 1? Well, what's 7 divided by 1? Show me with your fingers. 7 divided by 1 is? No, 7 divided by 1 is 7. Okay. Now we've got to know the basic, arithmetic operations. So make sure you convince yourself of that. And then 1 times 7 is 7, right? So I could write that as 1 times 7 and then finally as 7. Okay, does that make sense? Well, over here, write it out yourself. Just show me the same steps for x over 1 times 3 over x. And think about while you're taking the steps and what they mean. Okay, now I asked people to write out what we got here, and people went ahead and did that, and then they did the next step. Everybody did it. Okay, so you're proactive, you're thinking ahead, and that was good. Anyhow, this becomes x over x times 3 over 1 minus 6x. Well, so I'm not writing this out. So go ahead and bring this down, and this is gonna be 1 times 3 over 1. Why is it 1 times 3 over 1? Because x divided by x, anything divided by itself is 1. Okay? And what's 1 times 3 over 1? Well, that's the same as 1 times 3. Why is that equal to 1 times 3? Because if you divide something by 1, that's the same as counting to this number by 1s. How many 1s does it take to make 3? 1, 2, that many. That's 3. Okay? And we know that. Okay, then that's just 3. Okay, so this gives us 7, and this gives us 3. Here we have plus 4x and minus 6x with an equal sign. And everybody filled in these steps. I was happy to see that. Okay, well, it's a little tedious to write this out. I want you to write it out until you got it. So you don't think cancellation is some mysterious process. So now we have this equation. It's pretty easy to solve. You got to be careful. You got to use the rules. I'm still on the board here. Okay. Yeah. Well, you're going to want to get my x's on this side, meaning I want to get rid of the x on this side. Okay. Now I'm going to write it out in a way I don't prefer to write it out, but I don't have a lot of room here. So I'm going to use this space rather than this space. I'll just do what you are prone to do, and it's perfectly okay. I'm adding the equation 6x equals 6x to this equation. And that gives me 7 plus 10x equals 3. Now I would have written it out with the 3 minus 6x plus 6x and the 4x plus 6x. Usually I'll write it out like that because it uses less space. But you seem to do that. That works. Okay. Then I subtract, well, I add -7 equals -7. So I'm just adding something that I know is equal, something I want to make it, okay? And you subtract the 7 from the 7, you get 10x. Subtract 7 from 3, you get -4. So now you divide both sides by 10. And what do you do about 10x over 10? Yeah. You went through this process for 10x over 10? Make sure you can. Make sure you do when you write out your homework. Because it'll reinforce what's going on in a way that makes it much less likely that you're going to misapply cancellation in an analogous situation. We'll see situations later. It looks like something on a cancel. Got to be really careful about that. Without comment, I'm just writing down solution. X equals -4 over 10. Then we have to check that. Which involves some complex fractions. That's the reason we have the assignments and fractions. Okay. You can insert another assignment in fractions. It turns out you really need it. people usually, as I always say, in fifth grade, you learn how to do fractions, and somebody puts a calculator in your hand, and you never do them again. So you get to algebra, the expressions get complex, you don't understand the rules for fractions, and you can't do the algebra. All right. I'm just gonna jot down. Yeah. You get this. To check this, you're going to invert and multiply. Then you're going to end up with 4s in denominators here. You multiply everything by 4 and not have to deal with the fractions. Okay. This simplifies to negative 70 over 4 here, negative 30 over 4 here. You multiply by 4, you get negative 70 plus 16 equals negative 12 minus 60. Negative 70 minus 60. Negative 30 minus 60. My brain isn't clicking on that. And I almost have to write it out or take another minute to look at it. So I'm not gonna say what those equal, but those should check out. If they don't, it means I made a mistake. Now, at least one other person got this. So if I made a mistake, and you made the same mistake, it means you're following a great mind. Great minds think alike. I don't know what it means, but there are the steps. So correct. It checks. I looked at it once in a while, and you get 70 minus 16, which is 54, and you get 30 plus 24, which equals 54. So they work out. I was getting things turned around. I'm getting to where I have to write things out. I kind of hate that. Okay. Okay, so on the homework, which everybody that did it got 100% on the linear equations. So make sure that you're understanding the principles when you do it, because I see that people are still shaking some of the principles. You had equations like this, and apparently got the right solutions. If you didn't multiply both sides by 6, you did it the hard way. So try to do it the easy way. Now let's see what happens here. Write out this equation with your numbers. See if you can figure out what to do. Figure out at least the first step. What's our principle? We multiply by denominators, right? Well, we got 7 there, so let's multiply by 7. Now, then we've got to multiply both sides by 7, meaning we write 7, we put parentheses down, we write 7, we put parentheses down. Then in the parentheses, we put this side here and this side here. That's the rule. And if you do anything else, you're probably not following the rule. Okay, so I got those few dots here because I don't have time to do this fraction a minute over this point. That gives us x plus 49. But let's look at 7 times x over 3. Now what's 7 times x over 3? That's 7 over 1 times x over 3. And 7 over 1 times x over 3 is 7 times x. Multiply the numerators. And 1 times 3 multiply the denominator. Now what have we got? We got an equation that still has a denominator in it, but we've made progress. We've gotten rid of this denominator. We multiply by this denominator. Now, we're out of time. See, I've multiplied both sides. This side is here, this side is here. They're both multiplied by 3. I carry this out, just as we would have carried it out on this problem and this problem. Okay, identical steps, identical principles, and we get a solution. Now, I'll just comment, open math might show you, and maybe not. If you've got more than one denominator, then find a common denominator. If you multiply by any common denominator, it'll clear both denominators. So if I multiply by 21, which is a common denominator between 7 and 3, and it is the least common denominator in this case, but 21 is going to be divided by 7, and 21 is going to end up being divided by 3. Okay? And that's going to eliminate all the denominators. It's kind of slick once you understand that.